A very warm welcome to all the guests and fellow participants. Myself, Aman Shik from GSPM, Shao College of Engineering, and I am here to present our research on an enhanced intelligent LoRa-based wireless sensor network mesh architecture to improve the precision agriculture. So this will be the outline of our presentation. We'll first start with the introduction, then we'll move towards the motivation, and then we'll discuss the issues and challenges with the current scenarios. Then we'll look at the literature survey that the previous researcher have done, and then we'll move towards the problem domain, objective scope of the research, and we'll conclude the today's PPT. So, if you start with the introduction, then in India, about 60% of the Indian population is working in the agricultural sector, and India contributes about 18% GDP to the agriculture. Then, as the agricultural scales, the usage of groundwater, fertilizer, and pesticide will also increase, and this will also cause harmful effects on the land as well as the environment. Plus, if you look at the usage of the plus we look at the agriculture sector right now, it has already been causing the degradation of land due to excess use of fertilizer, and due to which the farmer lose the quality of the soil, and thus they lose the quality of the crop. So as a result, 10,000 around 10,000 farmers commit suicide every year in India due to lack of financial security. So if you look at the motivation, then India actually exports its majority of the crop to countries such as Bangladesh, UAE, and USA. The loss of fertile land is because of excess use of fertilizer, and the depletion of groundwater also is being caused due to this. Plus, if you look at the total land area on the right hand side, we can see the total land area from 1970s to 1990s. Then we can clearly see that from 1970s to 1990s, the land area increased, and this had a reason because of the green revolution that occurred in India. But after 1990s to 2020, we can clearly see that there is a decline in the land area, and this happened due to A, industrial revolution, B, industry buying the land of the agriculture sector, and C, people moving from the villages to the industrial cities such as Mumbai, Pune to work there, and they were selling their land. So this also caused decline in agricultural land. Next, if you look at the issues and challenges of agriculture, then as we all know, the fertilizers are heavily used in India. About 5 billion pounds of fertilizer we annually consume, and we can see that the fertilizer consumption has increased drastically over the years. Then, if we see the water usage of the crops, then we see that the wheat and the rice majorly consume a lot of water, and they are being exported uh, as a major crop from India. Then on the bottom right side, then we can see a graph that suggests us that from 2021, the demand is actually risen above the supply limit. So we are already in the danger zone, and we need an efficient solution to solve all of these problems. Previous researchers have done a lot of work in these areas, and we have selected the best research papers that try to solve this problem. And in the first paper, the authors have given a comparative study between KNN, CNN, LSTM, DNN, and HANN models for predicting the crop yield. This comparative study result was that hybrid ANN models performed the best out of all the models. The limitation of this research was further improvement in feature selection is required, and important feature like fertilizers wasn't even included. In the second paper, the authors have proposed the IoT based system that uses SVM regression tree algorithm, and the proposed solution was robust, adaptive, as well as the SVM model outperforms other classification models on standard dataset. But the authors, the limitation of this proposed solution is that they do not include implementation of crop fertilization aspect of the farmer, and the project was powered using power bank, which is flimsy. In the third research paper, authors have proposed a HANN algorithm for increasing the crop yield prediction. The authors have improved this algorithm by selecting the better feature, and they have concluded that the accuracy has remarkably increased. Additional features need to be also be considered for varied scenarios, and it could be improved further. In the fourth paper, the authors have proposed a machine learning IoT-based system for enhancing the irrigation of the crops. Optimized irrigation using soil moisture prediction was done, and they have also compared majority of the algorithms such as MLR, ENR, GBRT, and RFR algorithms. Other models can be used which better represented the non-linear data of the soil moisture. In the fifth paper, authors have proposed a smart LoRa-based system for monitoring the system usage using WSN networks. The proposed LoRa-based network is reliable and it is deployable. Plus, they have improved the efficiency and reduced the communication errors in LoRa-based WSN. The one major limitation is that the LoRa gateway processes a central point of network failure, and the absence of crop-specific management system is required, and only temperature and humidity were considered in the decision parameters. And the agriculture land requires majority of fertilizer, wind speed, etc. parameters need to be also considered. Plus, in the sixth paper, the authors have proposed a low-cost remote sensing node with help of LoRa network. And again, here authors have proposed the benefits such as the LoRa network showed a remarkable distance for sending the communication data. Plus, they also had efficient usage of energies, and also the cost of the overall system was lower. The system could be further be improved by and enhancing the usage of temperature, humidity of the soil, and environment of the field. The system lacks mechanism for controlling the actual structure. So this is the only part of sensing. Then also needed to be add the controlling part too. The problem statement for our project is that precision agriculture has potential benefits, but it is hindering because of various challenges such as limited access to technologies and skills, and the high cost of equipment and software make it difficult for the farmers to actually adopt these technologies that have been proven. So thus, we need a system that is that can be just easily deployed and that can be managed by some other third party. So this is the proposed system that we have proposed in our research paper. So as we can see, the system consists of a three-layer architecture, and in the bottom layer, it consists of LoRa mesh network nodes. These LoRa mesh network nodes are two types, sensing nodes and the actuator nodes. The sensing nodes sense the data and they push the data to the local database, and the actuator nodes are responsible for taking the decisions. The actuator nodes can control a pump and etc. In the local database consists of a MongoDB database that is connected to the global database, which is at tier 3. A tier 3 database actually takes the is a snapshot of the local database. If you look at the local machine learning mode for automation, then this mode actually takes the decision day by day and improves the quality, or I must say regulates the agricultural area on the basis of parameters such as humidity, temperature, and wind speed, other parameters. Then for the farmer side of view, we have got a dashboard. The dashboard consists of analytical algorithms that directly show the progress of the agricultural land. If you look at the higher level, then we can see that there is a predictive AI model. This AI model takes the data from the weather API and the some of the data from the global database, and this model suggests some of the improvements that can happen. For example, if there will be a rain in about 1 to 2 weeks, then this predictive AI model will tell the local machine learning model to stop giving or reduce the amount of water, because it will be because if you are expecting the rain, then we can already use the rainwater for that. So this is the role of the predictive AI model. Next, if we look at the 3D model of the field, then we can see that this consists of a sync node and all of the sensing nodes and actuator nodes. On the left hand side, we can see the WSN node architecture. And WSN node architecture consists of a central microcontroller that is connected to the communication module, and communication module communicates with all other nodes. The communication module uses LoRa technology for this purpose, and the microcontroller senses the sensing data from the sensors, and the data is actually analog or a digital input. Then upon receiving the data, the microcontroller can take the decisions for controlling the devices. The control devices consist of relays, actuator nodes, motors, pumps, etc., and the whole system is powered through PSU. And from the 3D model, we can see that each of the node consists of a solar panel, and the PSU directly takes the input from solar panel and stores it into the lithium-ion battery cell. So if the sunlight is not there, then the system can be autonomously powered through the batteries. And when the solar power is there, then the system can charge at the same time and also be powered to solar. So we would like to conclude our presentation. So the proposed research work done helps the farmer to improve the quality of the crop as well as the yield of the crop. It helps to reduce the wastage of the groundwater as we rely on natural resources by using AI predictive model to predict the future using weather APIs. Plus, it also helps to manage the fertilizer at correct time and what amount of the fertilizer should be given, because we rely on actual data. Plus, the proposed system is useful to individuals who have a way to automate, manage, and increase the production of the farm. These are all the references that we have studied. Thank you for your time, and